Hi and welcome to Adding and Subtracting Algebraic Fractions. Just before we start, just a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. Okay, so just to begin with, what is our method going to be for adding and subtracting algebraic fractions? Well, it's going to start with us finding a common denominator, then we'll find equivalent fractions with that denominator, we'll add or subtract the numerators and simplify if possible. Now, if that looks familiar, that's because it's exactly the same method as you would do for adding or subtracting any fraction. So let's give this a go. How do we find a common denominator is the first step here. Well, to find a common denominator, one of the easiest ways is actually just to multiply the two denominators together. We then know that both numbers are definitely going to be factors of that number. And so 5 times 7, well, that's going to be 35 on the bottom of each fraction. And what we've done is we need to make the equivalent fraction. So what have I done to the top, the first fraction? Well, I've done times 7. So I need to do that at the top as well. So 9a times 7, well, that is 63a. And on the right hand side, what have I done? Well, I've multiplied by 5. So a times 5 is 5a. What does that mean then? Well, the last couple of steps are that we just add the numerators together. So 63a plus 5a, that will be 68a, and it's going to be over 35. And we're always asked to simplify if possible. Well, the factors of 35 are 1, 5, 7 and 35. None of those numbers go into 68, and so that is the final version of this answer. In the second one, we have 5 over 3x take away 2 over 2x. Again, we need a common denominator. Now, what we can do is we can multiply these together, or we can just try to find the lowest common multiple. The lowest common multiple will be the best version here because it's going to help us to actually get to a simplified answer much quicker. So, what is the smallest number that 3x and 2x would both go into? Well, 3 times 2 is 6, and x would be a factor, so 6x as our lowest common multiple there for the common denominator. Now, what does that mean has happened? Well, on the left hand side, I've multiplied by 2, so I'll do the same at the top. It becomes 10. On the right hand side, I've multiplied by 3, so that's going to become 6. If I now want to complete the process, all it says is that I should be subtracting the numerators in this case. So 10 take away 6 is 4 over 6x. And we do just want to simplify here. Is there a common factor between 4 and 6x? Well, we can divide both of them by 2. So we've got 2 over 3x. And finally, 2 over 2x plus 3x over x squared. Well, I need to find a common denominator here. Now, how would I do that? Well, the common denominator, if I want to get it, I'm going to have x squared in each. And it's going to have 2 in there. So I'll use 2x squared. What have I done to the first fraction to make the denominator 2x squared? Well, that has been multiplied by x. And so I'm going to have 2x. What did I do to the right hand side? Well, I multiplied that by 2, and so at the top I'm going to have 6x. Now all I want to do is add together the numerators, so I've got 8x over 2x squared, and what are the common factors here? Well, 8 and 2 can both be divided by 2, and so that's just going to be 1 on the bottom, and x squared can both be divided by x, so I'll divide by x. It leaves me with 4 over x. Okay, so next, just a small step up with a little bit more complicated expressions, but still exactly the same method. We want the common denominator first. So we need to find that common denominator. The easiest way is just to 7 times 3, so they're both going to be fractions over 21 this time. And what's going to happen is the first fraction has been multiplied by 3. So x times 3 is 3x. on the right hand side it's been multiplied by 7. Now what I'm going to do here is I'm going to multiply the x by 7, so it's 7x, and I'm going to multiply the plus 1 by 7, so 7x plus 7. So now when we add these together, they're going to be a fraction over 21. And what we can see here is that we've got 3x plus 7x, so we've got 10x, and then plus 7. Now this one is as simple as it can possibly be, because 21 has no common factors between 10x and 7 other than 1. If we move on to 2x take away 4 over 3, take away 2x plus 1 over 5. Same thing again, I need to have a common denominator. So in this case it's going to be a common denominator of 15. And the first fraction has been multiplied by 5. So the top needs to be multiplied by 5. 2x times 5 is 10x. Take away 20. And on the right hand side it's been multiplied by 3. So that's 6x plus 3. And so what we have now, we need to simplify the numerators by doing 10x take away 20 take away 6x plus 3. So first of all, 10x take away 6x would be 4x. I then have negative 20 take away positive 3. Now it's very important here that this is negative 20 take away another 3, and so it's actually 4x take away 23, and that would all be over 15. Now if we're going to simplify this, we would need a common factor between all three elements. We don't have that in this case, and so 4x take away 23 over 15 is the simplest form. And then finally we have x squared plus 3x over x plus 4x plus 4 over 3. So the first thing I want to do is I need to get a common factor, and so if the denominators are x and 3, then my denominator is going to be 3x in both cases. And the first fraction, well, that has been multiplied by 3. Therefore, I will have 3x squared and I will have plus 9x. On the right hand side, this has all been multiplied by x, and therefore I've got 4x squared plus 4x. So then all I need to do is I need to simplify. So 3x squared plus 4x squared, well, that is 7x squared, plus 9x plus another 4x is plus 13x, and that is all over 3x. Now, have we got a common factor this time? Well, here we have x, x and x, and so we can cancel all of those x's out. If I cancel the x at the bottom and the top, it will cancel out the squared in this case, and so my simplified version will be 7x plus 13 all over 3. Now, just to go back to the very start, we could have actually made this a little bit easier for ourselves if we'd noticed that x was a factor of x squared and 3x. We could have cancelled out right at the very start, which would mean we were actually dealing with x plus 3 plus that fraction to begin with. But this is the full correct version anyway. And so we come to our final set of examples. We've got x over x plus 2 plus x plus 1 over x plus 3. And in this case, if we are going to try to find our common denominator, the key here is that we are just going to multiply together the two denominators. And what that means is we would have x plus 2 brackets x plus 3 on the bottom of each fraction. So x plus 2, x plus 3. And in this case, what we just need to think about is what has happened on the left hand side. Well, the left hand side has been multiplied by x plus 3. And so what we've got is x brackets x plus 3. As simple as that. On the right hand side, well, this one has been multiplied by x plus 2. And so we've got x plus 1, x plus 2. Now, what this actually means is, because they now have the same denominator, we can now write out the top of the expression, so x brackets x plus 3 plus x plus 1, x plus 2. We can write it all as one expression, all over the same denominator. But right now, that doesn't look particularly nice. What we actually want to do here is we need to now go through the process of expanding all of those brackets and seeing if we can simplify the expression in any way. And so the top of my fraction here, well, x times x is x squared, x times 3 is plus 3x. And then I've got x times x is x squared, x plus 2, x times 2 and 1 times x, well, that's going to be plus 3x. And 1 times 2 is 2. And all of that is going to be over x plus 2 times x plus 3. Well, that's x squared plus 5x plus 6. Can we simplify the numerator here? Well, the top of this fraction, it has x squared plus x squared. So I have 2x squared. I've got plus 3x and plus 3x. So I have plus 6x. And I have plus 2. At the bottom of my fraction, well, at the bottom, I still just have x squared plus 5x plus 6. And that would be the fully simplified version of that question. In terms of the subtraction question, exactly the same process. What I need to do here is, first of all, I need to write them both as fractions with the same denominator, and that denominator is going to be x minus 3, x plus 5 in both cases. And then the first fraction, the first one has been multiplied by x plus 5, and so that's going to be 3x take away 4, x plus 5. And the second one, well, that one has been multiplied by x minus 3. And so this is going to be 2x plus 2 times x minus 3. And again, we can now write that as a single fraction. And so this is everything that's at the top here. So 3x take away 4, x plus 5, that is going to be take away 2x plus 2, x take away 3, and it's all going to be over x minus 3, x plus 5. And so then we need to go through the process of expanding. So if we expand out all of our brackets here, so I've got 3x times x, that is 3x squared. 3x plus 5 times 5 is plus 15x. Negative 4 times x is take away 4x, and negative 4 times 5 is take away 20. And then with the second part, we just need to be very careful. This is a subtraction. So I've got 2x times x, so I've got take away 2x squared. I've got 2x times negative 3, so that's negative 6x, but it's a takeaway, so it's become positive 6x. I have 2 times x is 2x, but it's a negative, so take away 2x. And I have 2 times negative 3 is negative 6, but it's a negative, so that's actually plus 6. That's the top of my fraction. That's all going to be over, well, that simplifies to x squared plus 2x take away 15. And so then finally all I need to do is simplify the numerator. Well, I have 3x squared take away 2x squared, so that means I have x squared. I have plus 15x take away 4x, so that's 11x, plus 6x, so that's 17x, take away 2x is 15x, so that's plus 15x, and then I have negative 20 plus 6, so that's negative 14. Place that all over the denominator that we worked out before, so x squared plus 2x, take away 15. And so we end with the exam question. It came from the Edexcel paper in June 2017 and it was on higher paper 2. And it says that 2 take away x plus 2 over x minus 3 take away x minus 6 over x plus 3 can be written as a single fraction in the form ax plus b over x squared minus 9, where a and b are integers. Work out the value of a and the value of b. Now, this question has a couple of little elements to it. The first one is that the very first number is not a fraction. So we need to think about that. How are we actually going to deal with the fact that the 2 is not a fraction? And that's actually the easiest bit. The way to make 2 a fraction is to think, what do I divide 2 by to make 2? Well, I divide it by 1. So 2 over 1 is the same as 2 on its own. So then 2 take away x plus 2, x minus 3, take away x minus 6 over x plus 3. So the next thing is, this is 3 fractions that we're dealing with, but that changes nothing about our method. The method is still exactly the same. We need to have a common denominator between all of the elements in this case. And so the question is, how do I get that common denominator? Well, I multiply all of the denominators together. I've got 1 times x minus 3 times x plus 3. Now, if you have spotted it, this piece here, this is a difference of 2 squares. It is x times x and negative 3 times positive 3, and then the difference in between, that actually creates x squared take away 9. Now, why is that useful? Well, the answer said it should be over x squared take away 9. And so it is. So every fraction is now going to be over x squared take away 9. But the first fraction, the 2 over 1, what has that been multiplied by? Well, that has had to be multiplied by x minus 3 and x plus 3, which again is x squared take away 9. So my first fraction becomes 2 brackets x squared take away 9 over x squared take away 9. The second fraction, well, that has had to be multiplied just by x plus 3. And so this is x plus 2 being multiplied by x plus 3. But it's now over x squared take away 9. And the last fraction, well, that one has just been multiplied by x minus 3. So this is x minus 6, x minus 3, all over x squared take away 9. Let's work out what each of those elements are individually. So let's get the numerators in each case. So 2 brackets x squared take away 9, well, that is 2 x squared take away 18. X plus 2, x plus 3, well, that's going to be x squared plus 5x plus 6. And then the last section, that's going to be x squared take away 9x plus 18. Now, this is going to be a subtraction, but I'm subtracting everything in there. And this is going to be a subtraction as well, but I'm subtracting everything in there. And it can all be written over the same denominator, x squared take away 9. So finally, let's do some simplifying. I have, in terms of the x squareds, I've got 2x squared, take away x squared, so that's 1x squared, take away another x squared, means we've got no x squared, so the x squareds have gone. If I look at the x's, I have negative 5x, take away negative 9x, so that's negative 5 plus 9, so I have 4x. If I look at the numbers, I have negative 18, take away 6, so that's negative 24, take away 18, so that's 24 take away 18, negative 42. And that is all over x squared take away 9. Now the question said, we should be able to write it in the form ax plus b over x squared take away 9. Well, have we done that? Yes. In this case, a would be 4 and b would be negative 42.